Could a planet survive without a star? Most of us picture a planet the same way. A world circling a sun, a sky with a sunrise, seasons, light. So one of the strangest things astronomy has found is a planet that has none of that. No star, no orbit around anything bright, just a world drifting through interstellar darkness alone. These are called rogue planets, and they sound like a mistake in the universe. Planets are supposed to belong to solar systems. Rogue planets do not. Some may have been thrown out of their home systems early during violent gravitational chaos. Others may have formed on their own, more like tiny failed stars. Either way, the result is the same: a planet with no sun. And once you hear that idea, the next question comes fast. Wouldn't that world just freeze solid forever? Maybe, but maybe not. That is why rogue planets matter. They bend one of the most basic rules people think they understand about planets, that you need a star and the right distance from it. Because if even some of these dark worlds can stay warm in the right places, then the galaxy may be stranger and potentially more habitable than our usual picture allows. The first weird thing about rogue planets is that they are probably not rare curiosities. They are just hard to see. Most exoplanets are found because they pass in front of a star, tug on a star, or glow near a star. Rogue planets do none of that, so astronomers often find them indirectly using gravity. If a rogue planet passes in front of a distant background star, its gravity can briefly magnify that starlight. This is called microlensing. It is one of the few methods that can catch a planet with no host star at all. That matters because the numbers could be enormous. NASA-backed studies have suggested the Milky Way may contain trillions of rogue planets, and one 2023 NASA summary of microlensing work described an estimate of roughly 20 times more rogue planets than stars in our galaxy. That number is still an estimate, not a settled census, but even the possibility changes the scale of the story. We are not talking about a few cosmic outcasts. We may be talking about a hidden population. NASA's Roman Space Telescope, expected to begin work in 2027, should push this much further with a huge microlensing survey that can detect many more free-floating worlds, including smaller ones. So the first big idea is simple. The galaxy may be full of planets that do not belong to suns at all. The second big idea is even stranger. Some of them might not be completely dead. At first, that sounds absurd. Without sunlight, a planet's surface should plunge into deep cold. No blue sky, no photosynthesis-driven biosphere like Earth's. But a planet does not get energy from only one place. Worlds also contain internal heat. Some of it comes from the leftover violence of formation. Some comes from radioactive elements decaying inside the rock over immense stretches of time. On icy moons like Europa and Enceladus, internal energy may help maintain oceans beneath frozen crusts. That is the key mental shift. A rogue planet does not need to look like Earth to stay interesting. It could be more like an isolated ocean world sealed under global ice. And there is an even more radical version of the idea. In 1999, planetary scientist David Stevenson proposed that an Earth-mass world thrown into interstellar space might still keep liquid water if it held onto a very thick hydrogen atmosphere. That atmosphere could trap geothermal heat so efficiently that liquid water might survive. That is not a proven description of real rogue planets. It is a serious scientific possibility. More recent modeling has kept the broader idea alive. A 2022 study in Nature Astronomy found that cold rocky planets and super-Earths with thick primordial hydrogen-helium atmospheres could, under the right conditions, maintain temperate surface conditions for billions of years far from a star. That study was not saying rogue planets are confirmed living worlds. It was showing that the old picture of habitability is too narrow. Distance from a star is not the whole story. Atmosphere matters, pressure matters, internal heat matters. And once you accept that, rogue planets stop sounding like frozen leftovers and start sounding like a different category of world entirely. There is another reason this topic matters. Rogue planets tell us how violent planetary systems really are. We like to imagine solar systems as neat clockwork, but young systems are messy. Giant planets migrate, orbits cross. Smaller worlds can be tossed inward, destroyed, or flung out into the galaxy. If we find a lot of rogue planets, that is evidence that planet formation is not calm. It is a brawl. So these worlds are not just exotic destinations, they are fossils of planetary chaos. And they may tell us something else we usually ignore. A star is not always a blessing. Stars provide energy, but they also blast planets with radiation, strip atmospheres, and destabilize climates. A rogue planet loses sunlight, but it also escapes that stellar violence. If life ever existed in a buried ocean on such a world, it might live in a place that is cold, dark, and chemically powered rather than sunlit. That sounds alien because it is. But even on Earth, sunlight is not the only energy source life can use. Deep-sea ecosystems around hydrothermal vents run on chemistry, not daylight. That does not prove life exists on rogue planets. It just means the concept is not fantasy. And astronomers are beginning to study isolated worlds directly. In 2025, Webb observations of the free-floating object SIMP-0136 showed that even a starless planetary mass object can have a surprisingly complex atmosphere, with clouds, temperature changes, and chemistry that vary as it rotates. So these lonely worlds are not just dark rocks. Some are dynamic places. What scientists still do not know is most of the important part. We do not know how many rogue planets are true planets that were ejected, and how many formed more like brown dwarfs. We do not know how many are rocky instead of giant gas worlds. We do not know how often a smaller rogue planet can keep the kind of thick atmosphere needed to trap heat for billions of years. And we have no evidence that life exists on any rogue planet. Right now, habitability in these worlds is a serious idea, not an observed fact. But that is exactly why the payoff is so good. Rogue planets force a correction in how we think. A planet does not have to stay where it was born. A habitable world may not need open skies. And the galaxy may contain a vast dark archipelago of wandering worlds that almost nobody imagines. We are used to asking how many Earth-like planets orbit distant stars. Rogue planets suggest a harder and better question. How many potentially interesting worlds are out there with no star at all? And if a planet can stay warm in deep space, then the next idea gets even bigger. Maybe the real problem is that our definition of the habitable zone has been too small from the beginning.